Welcome, everybody, to Dallas Personal Robotics Group Robot Builders Night Virtual for Tuesday, April 21st. Tonight, we will do our normal presentation of projects and open up the floor to any questions or comments that people have. So just a couple items for housekeeping. A reminder that May 23rd, the DPRG will be holding our Roborama for the spring, and with several competitions that I'm trying to remember off the top of my head, but I don't have it. There's advanced line following, there is quick trip, there is sumo, there's 6-can, and barrel racing. I think I got them all. As well, this Saturday coming up, we will be having our DPRG monthly meeting, and on April 25th. And the meeting will be highlighted by Sensori Robotics. We'll be doing a demo on a Unitree go-to robot dog. So they will be on site at the Dallas Makerspace, 10 a.m. local time, and they'll get going and do a presentation on the dog. So look forward to seeing that on Saturday. It'll be hosted live as well as over our normal video channel.
And just a reminder, we're in the back room, not in the normal room. We're in the interactive room.
They're in the interactive room. Okay, thanks, Mark. Presenters tonight, to kick us off, we have Mike. Give us an update on his barrel racing robot.
Okay. Yeah, so I've got it working faster. I've worked on the sensors, and I found out that my odometry was messed up. And what was happening with the odometry was my wheel control that spits out the odometry messages was spitting out a whole bunch of debug messages and swamping the ROS topic infrastructure, what do you call it, DDS, and it just wasn't happy at all. So I figured that out and made the odometry a little better, and also I've been working on getting the LIDAR scan data motion compensated to try to get it more accurate, and it seems to be better. But I can show tonight the my barrel racing running at 0.3 meters per second. I really wanted to get it to 1.5 to 0.5 meters per second, but at least it's better than 0.1. So and so what I'm going to do is I'm going to show the RViz screen, which will show you the non-compensated LiDAR data and the compensated LiDAR data. And you can see where they diverge and come back together when it stops moving and stuff. So, and then I'm going to show you the, I'll point my camera at the field, try to keep the robot in it. So I'll have both a shared RViz, which I'll do right now. Okay, so I'm sharing my RViz screen or window, and then I'm going to point my camera. So you should have it in should pin the camera. Can somebody pin it, or?
I did pin it.
Okay.
It's smaller on the side.
Okay.
Your main screen takes up the most.
Oh, okay. I had something weird going on. So here's my setup. You can see the robot sitting over there. So in barrel racing, it starts here, which is 2 feet from the start, and then the cans can be 2 feet or 3 feet away, and 6 feet or 8 feet apart. And so this is barrel 1 here, and I think that's off the screen. It's barrel 2 and barrel 3. So I'm going to push the button, and it's running at 0.3 meters per second. And hopefully it's happy. So you can yeah. Oh, I set this barrel off, so it found it. Then it found the other barrel. So it's going around barrel 2. And it's going to go to barrel 3. And it'll head back to where it started and turn around just because it can.
All right.
That's brilliant, Mike.
That looks
Yeah,
really nice. Like, a lot of progress.
Yes. Yeah. So
No,
Nice.
yeah.
Cool.
so is our vid showing for you guys?
Hmm?
Is our vid screen showing?
Yeah.
Okay, good.
Good.
Okay, so what I can do is on the RVID screen. I don't know if you can see the cursor. Maybe you can.
Yep.
But there's the red and the green, and they're overlaid right now. So the red is the non-compensated scan data, and the green is the compensated, motion compensated scan data. But since there's no motion, they're perfectly overlaid. And what I'll do is I'll just rotate the robot for rotational compensation, and you'll see that the green stays relatively stable and the red has an offset. And then I'll turn the other way. Yeah. So the rotational compensation worked pretty well. Straight here. So you can see that I'll do it again here, but the green line basically stayed where it was at. It's still not perfect. And the red line is lagging it or having difficulties. And it still has some issues with when it starts and stops movement. And then if I go forward, you can see that the red and the green lines diverge, and the green line stays more consistent. So this is what I was using for determining if my motion compensation is compensating, and it seems to be improving it. It still has some issues, I think, with some lag data with the lag data, but in general, I was able to change the range or just modify the variables inside of the scan and put them back out to compensate for it. I could. Okay. Well, before I turn off the RViz, does that seem reasonable? Did you think? I'm thinking that it's better. I was wondering if people thought it was better.
Yeah.
That's cool.
So I have a question. I don't know if for anybody else, but when I was looking at the live video of the robot moving, at the first can it just stopped, and I didn't see it go the rest of the way. Did everybody else skip the whole video?
I saw it.
Yeah.
I saw the video.
Okay, yeah. So my little inset, it's the robot stopped at the first can. I could see it moving on the RViz. So I guess that was just something with my connection.
Okay,
Yeah,
sorry about that.
the can did a turn. The robot did a turn right in front of the can to go around it.
Okay, yeah, and it stopped right when I got to the can. It stopped for me. So thanks for that update.
It did a little stop. It did a turn to the left, and then it wrapped around the first can.
Yeah, I figured everybody else saw it because from the comments, oh, cool, neat. So that's been I just missed the excitement.
Gold star, Mike.
One interesting thing is I put the first barrel can, which is here on the screen. I put it on the wrong. I put it 3 feet away from the start line, but barrel 2 is only 2 feet from the start line, so it had a little bit of alignment issue. If I move the can here, so now they're more lined up. You can see it moved on the screen here, on this screen. But so that's why it acted a little funny on the barrel 1. So, but even if it was off by a foot and it wasn't perfectly adjusted to 6, yeah, it still was able to figure it out and do the race, even though they weren't where they're supposed to be. So that's a good thing of this using the sensors is I don't have to tweak stuff in. I can just point it and it'll find them and go around them. Let me see, stop sharing RViz because it's not going to show you anything much better. And if I go and share my development screen. Oh, that's not the right one. Share. Oh, here it is. Yeah. Yeah, so let me get rid of a bunch of stuff here. So this is the compensation I did where I'm extracting the data out of the message, out of the scan message. Like this is the scan message callback. I'm getting the laser scan data. Then I'll just go through here quickly. I process it, and then I update the data that I changed, and I publish a new message, which is the fixed scan message. And so what I did is in angular velocity, the angular error is the angular velocity, which is radians per second of rotation times the scan time. The scan time is taken out of the message scan time. So I'm just getting the scan time, which is how long it takes for the LiDAR to rotate one time for that particular. It's pretty variable when you look at the scan time. So the LiDAR has a PID loop in or something and it oscillates. So I just read the scan time and said the angular error is the velocity, the current velocity, and I'm getting the current velocity from the odometry from the wheels, and I'm multiplying it by the scan time, and then I add it to the the scan data goes typically from minus pi to plus pi, or plus pi to minus pi, where a max is usually pi and a min is minus pi. And so what I did is I said, well, when it's rotating, it has an angle error, and so I'm adjusting the minimum, so it's going to rotate. So the data is going to go from pi to minus pi plus or minus this angular error, and then that changes the scan range of angle, and so I had to recalculate the increment for each of the rays, each of the scan data rays, and so I took the difference, which isn't exactly 2 pi anymore, and divided it by the number of rays. And then for the linear data, I took the linear velocity times the scan time, and then I added that distance error to the range variables, the distance data, and I adjusted it by a linear curve, so that the first data point has no error because it's right there. But then as it's rotating around and it's moving, then the distance error changes. And when it's going forward, then the data is like a plus error. And then when it's the scan data is going backwards and it's moving forward, then you have the opposite data distortion error. So this linear curve is I calculated it here, which is I created a line from 0 to 1, and then multiplied 0 to 1, so that it always starts with no error, no correction, and then I did the cosine of 0 to 1 times math 2 pi, so it has a cosine function. So it puts out a sort of a squirrely wiggle. It's not a cosine function. It's sort of a modulated cosine function. And then I saved it as a linear curve, and that's what I used in this. So this was my correction, and it seems to be okay. I tried to do a lag compensation, but it didn't seem to help. Well, I got to work on that some more, because when you saw RViz, you would see that it would jump and then go back, and that's shit. I think that's because the odometry and the scan data have some lag. So I got to figure out how to get that lag. I tried to calculate the lag time, but something's not working out. It's not getting a lot better or any better. So I got to work on it. So that is my little presentation.
Question, Mike. You said that the LiDAR scan time is quite variable. How variable is it?
See, like nominally it's 1. I've never seen it go or 0.1 seconds, but I've noticed it goes from 0.8 to 0.1.
Wow.
Wow. That's
Yeah,
a lot.
Yeah, I mean, when I listen to my LiDAR, I can hear it modulating. so something's causing it to modulate.
So you're saying 0.1 to 0.8, so a factor of 8 difference?
Oh, 0.1 to 0.08. I'm sorry.
Okay, okay, thank you. Big difference.
Yeah.
Wow.
So like a 20% change.
Good to know.
And I'm not sure what it's doing. Maybe my power supplies have a little variation or something that's causing it to change, and then then there's a feedback loop that corrects it, and so it's sort of like, yeah, it's not completely stable. It moves or it changes.
Yeah, it sounds like the PID loop that they're using to control the motor might be oscillating.
It's oscillating, but something's disturbing it, and it might be the power supply. So not sure. Yeah. So, okay, so I'll stop sharing here. Stop presenting. Okay.
Well, that was excellent, Mike.
So hopefully I can get it to 0.5 meters per second. Because since I corrected the LiDAR, I haven't tried to increase the speed yet. Yeah. I was able to increase the speed when I corrected the odometry data from that overload function. So maybe it'll work at 0.5 now. I just haven't had time to test it.
Nice. Nice robotics work.
Yeah,
It is.
so,
That's
so all this is the fundamental stuff, so it's going to help my other competition modes. I can run them faster. Maybe I can collect the cans faster now. Yeah.
Yeah, maybe. All right.
Next up, we have Paul.
Okay, so let me pin. pin the cell phone picture and also share share this. So my friend Rich and I disassembled one of those RoboMo 612Ps that we got from Sensori, and took a bunch of pictures as we did so, and so I've documented the findings. So we've got a shared folder that's public readable called Mowberry, and let me just because it's the name of the robot, let me just paste the link in to the chat. Okay, so there's the link, and under Mowberry, under hardware, under mower teardown is this mower and dock teardown document. And so I thought I'd just step through it and show where that stuff is on the real robot. So you got a power switch over here, and I should get a flashlight so I can illuminate some of the stuff. It's a bit dark. Yeah, so got a flashlight. I got a power switch, and then I gave and then if you open up the electronics cabinet, you get the main circuit board. There's just that's this that's this module. It's got some clips here and around on all sides. So it's
You're not showing it, Paul.
what?
Your camera was off, I believe. It's the
Yeah, we're not seeing the module.
yeah.
There you go. Okay, that's better.
Yeah. So that's the clips that open it up, and when you open that up, the LCD assembly folds up with the lid, and you see the main circuit board with all these connectors going to it. And so you've got a connector for the left blade motor, the right blade motor. The front sensor board is an interesting one. That's where a lot of the magic happens. And then the cable going off to the LCD panel on this top row of connectors. And then once you take them off, below that you have a connector going to the GSM board and to the buzzer. So it's got a GSM board like right here. Let me see if I can. Yeah.
Is that a 2G board? Probably.
We think it probably is. Rich has one from 2015, and it's a 2G board. So that and the blade motors are cabled around through here back to the electronics enclosure. The other blade motor comes back on the other side, and then also what comes in on the side here is a black cable here that goes to the front sensor board. So front sensor board is like got all kinds of magic in it. So anyway, you can like pull the whole thing apart and labeled all the connectors. So here's the block diagram of the thing from a harness perspective. You've got the main electronics board connects to the LCD panel through that ribbon cable, then two 10-pin connectors to the blade motors. There's a connector going off to the GSM board, a connector coming in from the battery, which lets the main as well as the main battery power cabling that goes through the fuse and the power switch. So that lets the electronics sense the voltage of each cell. And then much magic happens on this front PCB, and I'll talk about it in a second. But it's got the collision sensor, the caster lift sensor, the blade housing lift, maybe, and dark approach sensors, and maybe other things. And wire sensors too. I didn't put that down. And then exiting out of the bottom of the electronics enclosure is the cabling to the left and right drive motors, which do not have encoders, interestingly enough. So the front sensor, so let me just turn this guy around.
I have a question about the battery.
Yeah.
It's measuring the cell voltages. Is there a battery management system, a BMS, on the main electronics board for charging?
I think Paul has it. Paul, you can probably address that because you've investigated that more than me.
Yes, so it does, and unfortunately, I don't have it with me. I had to go to my office today, and I was going to make some measurements and got busy, and I think I didn't pack it back up. But yes, what I do have is so here's the battery pack, and this is where the boards would set here. You can see the connector here. This goes directly to all the cells and then plugs into the BMS. I don't know. Can you see that? So there's the board is a long board here. It's got an aluminum heat sink on it. In fact, that's the heat sink from it that sits down on the FETs. And then there's another the cable that the 10-pin cable that Paul shows on his drawing has another 8-pin cable that plugs into the end of the board and then goes off along with the large connector. So, but there are, in looking at the board itself, for the 8 cells, you can see a pair of, I'm assuming they're FETs. I haven't looked up the part number, but a pair of FETs for each of the 8 cells, for being able to control, to balance them out. So, and it has 2 20-pin SOICs on there, and I haven't been able to identify them yet. But I'm assuming that those are, one of them serving 4 cells and the other one serving the other 4 cells, driving the FETs. So it's definitely got some intelligent, power management on it. But, exactly what it does is we're not sure. The other thing that's interesting is if you go look on the main board, let's see if I've got one here. Yeah. So if you look at the main board, and I don't know how well we're going to be able to see that here, but this here, let's see here. This is the connector that comes from the motor. From the battery management pack. So they do some kind of a connector change, but down in this area here, and I don't know if that's going to show it, but you can see there's a bunch of transistors. There's pairs of transistors. Here's one row, and then there's another row. So and I don't know if that's just for level shifting or if somehow they have the capability to do charge balancing on this main board. It's not clear yet. So all I've done is kind of just dug them apart. That's a TBD that is on Paul's list. This Paul, maybe that Paul.
Yeah. So the front PCB where all the front sensors connect in is under a clear glass cover that lets optics shine through it. I've got the cover lifted, unscrewed on this robot, but what you've got. So I think I want to talk about the bumper because I'm most impressed by the bumper design. So you see this? Do you see this? Let's see if I can illuminate it. This springy thing, it's like kind of like bend sideways, and there's 4 of them. One there's one over here, and there's one over here. And so the way it works is the way collision detection works is this is the bumper, and it's underneath. It's got these 4 receptacles, 4 like spherical receptacles. 1, 2, and then there's 3 and 4. And so what happens, and then take a look at this thing. This is actually a magnet. And so we believe that the way collision detection happens is when the robot bangs into something like a wall or something, that bumper assembly actually moves on these springs and kind of shimmies around. And the magnet that's mounted on the top side of underneath the bumper, but on its underneath its top surface, right behind this little sensor thing here, this little circuit board, and I think there's a Hall effect on the back side. You can't, and so any disturbance of the bumper of enough to trigger it would cause a Hall effect output disturbance, and so that would the magnet would cause this Hall effect to output a change in signal, which would be interpreted as a bump, and then it would back up. So I'm very impressed by that. That's very clever.
Yeah, it seems like it could also detect a left or a right strike. Yeah.
No, there's no left or right. Any disturbance, and it'll back off and try and turn away, turn in some direction. But there's no left or right.
So, Paul, are you saying that the magnet is centered on the Hall sensor, so any movement that moves it off center from any direction, that's what it's detecting?
Yes, I believe that's. I don't. This is. Let me just say a disclaimer that this is supposition, because that's the only way that I can figure it could work. Because it's definitely a magnet. It attracts screwdrivers, and it definitely sits right behind this thing. And there's nothing else. There are no micro switches or reed switches or anything that are connected to the bumper assembly. The bumper assembly just sits on top of these 4 spring things, springy posts.
Yeah, it would need to have multiple Hall effect sensors kind of arranged in, equally spaced that, when it moved over them to kind of get a direction sense.
Okay.
Bump sense.
Yeah, and so, well, I don't know what it does in that level of detail, whether it can sense directions or whether it, the direction of a bump or whether it just reacts to a bump in any direction by backing off. So anyway, I think that's one of the cleverest things about this design. Another thing of interest is if you look down here, there's some browny gray cables that are shielded cables. They go down to the coils that pick up the signal from the signal from the wire that goes around the perimeter of the lawn, and the sensors themselves are actually inside this bar. So there's one on one end of this crossbar and the other on the other end of the cross member. And so so that when it's following the line, it'll keep the wire centered between these two sensors. Otherwise, when it's roaming around, mowing the lawn, it'll as soon as either of them detects that it's crossed the wire, then it'll back up and turn away from whatever direction, whatever side hit it. Apparently, these wires are an inductive loop. Apparently, the wire is an inductive loop antenna, and apparently it's magnetic, not electromagnetic. And so apparently it uses the right-hand rule. So you got current going through the wire and a magnetic field going around it. And on the inside of the coil, the field comes up. On the outside, the field goes down. So that's how it knows whether any given sensor is inside or outside of the loop. So I didn't know that, before, but that's pretty clever.
Mhm.
Another clever thing is the lift sensor. So it detects if you lift the front of the mower, the caster here is on drops down, and you can see this rod will drop as I lift it. And there's it's magnetic too. So there's a Hall effect apparently inside there that detects when that magnet moves away from it, owing to the caster having dropped. There's a group of LEDs here. At least one of them is a flashing red LED that flashes while it's operating. And then this thing, Paul and I have done some investigation on this, and we believe this is a photocell, a photo detector, to help it docking, to help it align with the dock as it's homing in, trying to reach the dock. And again, this is like some degree of supposition, some degree of looking at what components are, and think about how it has to work. And then down in here, you've got the charge pins protrude into these two holes here, and stick into these metal contacts, and then when it detects that the mower is connected, it turns on 24 volts or whatever voltage they have on that thing. Another thing that I think this isn't to do with robotics, but I think it's kind of interesting. This mower deck floats on a four-arm, so it's got a four-arm assembly that keeps the angle of the mower deck constant as the deck rides up and down over bumps and stuff. So anyway, I documented all of that, pointed out the wire sense cable and the caster lift magnet, and I've got it labeled as a camera question mark, but we've pretty much decided it's a photocell at this point. And unfortunately, this PCB is all covered in plastic, and you pretty much have to destroy it to get it out, to get the PCB out, so you could like ohm some stuff out. So it's sort of difficult to get at. It also has so the red bar is both a depress to stop button and a carrying handle, and it's got I don't know if you can see it, but there's an orange. If you look down behind the handle, there's an orange tab that that moves with the handle, and it's magnetic too. So I think that there's a Hall effect sensor on the back side of the PCB that's right behind that wall that is detecting stop button depression or lifting.
So, Paul, it sounds like one of their design objectives is to have no mechanical switches given the environment it's going to be, since it's made to be left outside with all the Hall effect switches and all the optical coupling.
It sure seems that way, and you know, it's honestly, it's a nice design. It's a really nice piece of design.
Or the saleswoman was really cute that they're selling the Hall effect sensor. So
I have a question. The motors, driving motors, it has 3 wires, like black, red, and white, I think. What is the third wire for? Do you know?
Best I've been able to tell, it's case ground. So there's really only 2 wires, no encoder.
No, but on the connector, there are 3 wires from driving motors.
Oh, you know what? There could be a thermistor in there. I'm unsure on that point. I'm sorry. I'm unsure on whether there's a thermistor in there. And I don't have one of the unmodified motors in here to measure it real quick, unfortunately.
okay.
Maybe
talking
maybe later
about-
on in the meeting I can.
Are they maybe a brushless motor?
Yeah,
No.
3 phases.
The question was about the drive motors, and those are not brushless. They're DC.
Oh, okay.
Yeah, the blade motors are 3-phase brushless.
Mm-hmm.
So the dark electronics is interesting. It's all covered in plastic, like the front PCB, so it's difficult to tell what's in it. But we pulled one apart and tore the plastic off of it, and so there's a couple of big components that have been removed from it, but it's got a big transistor there on the left that is used to switch the 24-volt charge current from the dock onto the pins, onto the rods or charge rods that feed into the robot, so it can feed charge power. This connector is where the wire the wire loop hooks up. It's got an LED, a 2-color LED, red and green for flashing fault codes. There's a little microprocessor down there, STM32F51, that flashes the LED and turns on the charge power, and I'm not sure what else it does. It detects if the wire loop is open, and not entirely sure of all its functions. What's interesting is on the back side. So this is the side of the board that's faces the mower as the mower approaches the dock, and you've got 2 LEDs there with a kind of a little black optical isolator between them. And the theory is that if the robot is coming from the left, it will only see one of those LEDs. If it's coming from the right, it'll only see the other one. And I think that the LEDs must flash a unique pattern so the photodiode that I pointed out on the front front sensor board is pretty sophisticated. It's a lot more fancy than just a photodiode. It's got an AGC circuit and a pulse detection circuit, and it looks for a string of 30 or so pulses, and then says, "Okay, I've seen active from the from the other end, from the transmitter. And then there's a specified delay period, and then another string of pulses is emitted or not. So effectively, they can send a fairly low baud rate signal across out of the LED, where each bit of the signal is represented by 30 really quick flashes. It's a 38 kilohertz flash rate. And so they could potentially, and I don't know if this is what they actually do, but they could send out a different code from the left and the right. They can even send, AI suggested that they even send the mower type that it's meant to mate with, because Rich found that his old dock wouldn't charge, the mower wasn't happy docking to his old dock. He had to change to a new dock electronics that matched the mower. So that it does make sense. It does sort of like correlate with experience that they would be checking the mower would be checking the dock model to see if it matched. But anyway, that's I think that's how it hones in, is by moving from left to right and seeing one pattern of one pattern string of bits coming out of one LED, or the other pattern coming out of the other LED, and then trying to oscillate between the two as it drives forwards. So
quick question. So where did you find the information about like the 30 pulses? Which is pretty detailed info. So just kind of curious.
Yeah, that was in the TOP. So you should be seeing my desktop here. I think the device that I think the sensor is a TSOP 62. What? I forgot the last two digits that I determined it was. 62 something TT. And you can see the block diagram here. Expand it a bit. So here's AGC, a bandpass that only lets 38 kilohertz signals through, and then a demodulator and a transistor output that is the signal. And then here's the pulse train. So this is showing the test signal, 30 pulses, taking 10 milliseconds to be emitted, or having a 10 millisecond period. And then here's a string of those pulses representing different bits. So when it sees the bits coming out, after a little while, when it's determined there are bits, it drives the output signal low and then back high again. And then if you zoom out and look at the strings of pulses coming out, each of them being 600 microseconds long, and it looks like they maybe have a frame time of 60 milliseconds. So that sounds like about 10 millisecond period between bursts. So that would be 6 bits coming out. Then it would output this pulse. So you can imagine them sending or not sending these bursts of LED pulses, and consequently getting a output signal that is some digital string that a UART could understand.
Yeah, I guess I wouldn't. My sense would be that's just more their test, the way to test and validate the IR receiver. But I wouldn't necessarily take that to be the protocol that's coming over universally. I guess that was the question that I had, was not so much the analog front end part of it, but what the determination that it's sending a 30-bit code I mean, I would think it could be anything that's 38. It's just got a 38 kilohertz, carrier. Not trying to be contrary, just trying to understand.
By looking at the chip, it's probably just like a common chip that's used in like a TV remote. So my guess is it would work very similar to a TV remote, and so they could send all types of signals across.
Yeah, I guess that was my point. Is that I don't know that the format would be locked to the test signal per se.
Right. I didn't mean to say that the test signal was what would get sent, but just the concept of using bursts of pulses to overcome sunlight and fluorescent light and all kinds of optical interference that they talk about, as well as electrical interference. And then an AI proposed that they send a mower model code or a dock model code across the link. That's just an AI talking. It may or may not be true, but the experience that Rich had that the wrong mower won't work with the wrong dock suggests there may be some truth to that.
Yeah, it makes sense.
Yeah, it's similar to the way a universal TV remote works, to where you can basically have different signals for different brands of TVs.
Yeah.
Yeah, I think there's a couple different standards for that. I know NEC had one. I think Samsung has another.
Yeah, Sony has their search. And by the way, while Paul, while you were looking at that, I do have one of the original motors, and I did do a measurement, and you are correct. That third wire, that yellow wire, is case ground on or it connected to the case of the wheel drive motor.
Thank you, Paul. So there we are. No thermistor, I guess.
No.
Huh. So that's kind of interesting. Maybe using the motor can as a shield.
Yeah, I'm going to guess it's EMI suppression.
Yeah.
Sensori did put both a single channel encoder and a thermistor in the cap that they put on the back of the motor. So actually, you guys might be interested in that. Let me just bring that up.
Yeah, it's kind of curious why they potted that board. I mean, you think there was proprietary circuitry on it or something? Or
good question, Ray.
Yeah,
I don't know.
It's like I don't know how long it took you to dig all the plastic off it, but you
it was a while. It was hard.
It's probably just moisture protection.
That'd be
it could be
To protect it if any water got kicked up or dew off the grass.
Yeah, I didn't think about that.
So I'm going to share. See, I'm going to unshare this and share a different window that I think you guys will be interested in. This one. So this printout diagram for the motor. And so they got two ground pins, motor black, motor red, wheel out. I misspoke. They did not bring out a thermistor, just the wheel out, which is the encoder, single channel encoder. So no thermistor on the wheel motor. I did an interesting experiment since we know that RoboMo didn't put an encoder in their wheel motors. I was like, okay, well, so what happens if I lift the back end up and put a brick under it and let the wheel spin, but the robot doesn't move? And it wasn't too long at all before it started jiggling backwards and forwards and spinning its wheels in alternate directions, clearly trying an escape behavior. And then then it issued an error message saying that it was stuck and stopped. So Paul and I concluded that that must mean it's got an IMU, that they use an IMU for verifying that the thing is actually moving versus relying on using encoders for anything.
Gave out the "I've been bricked" error message. 2 bricks under the back.
Yeah. So anyway, that's all I had.
Cool.
It was a very interesting and kind of neat exploration into really quite a beautiful piece of engineering.
How old do you think that design is? Is it 5 years?
Well, so the mower was built in 2019, but Rich says that in a lot of ways it's very similar to his 2015 mower. He's not quite sure about whether all the front sensors and deck mechanism is the same, and bumper mechanism, but so probably somewhere around 5 to 10 years. Probably on the upper side of that, I would guess.
Yeah.
Yeah, to echo Paul's comment, it's very nicely designed. The circuit board is very well marked. Cabling is nice and neat. It's very well done.
So anyway, that's all I had.
So did I'm assuming Sensori was Mr. Melbourne?
Correct.
So did they focus on these models or this model in particular for some reason, or?
I don't know their reasoning for using this model.
Oh, okay. I was kind of curious. Maybe it had good reliability or something.
Yeah, I don't know.
It was a time it took a licking, kept on ticking or something.
That same platform was used by a bunch of different vendors. Is that not correct, Paul?
Yeah. It's also sold
OEM.
in the Husqvarna and Cadet, I think, and about like Paul says, a bunch of different vendors sell this platform. So,
So they all look the same underneath, or just maybe different markings on the outside or something?
I can't answer that in any detail.
Yeah.
It's just from reading. You find that like the motor is also used in the Husqvarna, and then an AI tells you that the sensors are also used in Cadet. So,
Yeah.
So one thing that this group would appreciate in terms of the engineering, so they have a service menu that you can get to on the LCD panel, and there's a universal code that's 897 for all of them. And one of the screens that you can get to actually shows you the voltage on each of the 8 cells, as well as the total voltage and a couple of other things. So it's really handy because a nominal full charge voltage on those, they're lithium ion ferrite, or whatever the correct name is for that. And I've noticed that when I'm charging my batteries that haven't been charged in years, that it takes 3 or 4 days for all the cells to get up to 3.6. Some of them will come up maybe after a day. Some of them, a couple of them cells in this one pack were at 3.3, and it took about 2 days, but they eventually got all the way up to 358, 359. But it's really nice to have that monitoring ability right there on the screen. You can sit there and watch it, and that'll tell you if your battery's good or not. Good stuff.
Are those like 18650s, or I think there's another one was a 21700 or something?
I don't know if you can get a sense for the cell size here, but that's the cell. It almost looks like a sort of a long C cell, if you will. It's about the diameter of a C.
Oh, okay, yeah. So that's
one cell right there. So it's an 8S2P. So it's got
8 in series, 2 in parallel.
Yeah.
Yeah, so that's that.
And it was 24, the kind of the nominal
Yes.
voltage.
Yeah. The nominal voltage.
Yeah.
Another interesting thing is the reason for using LFP cells, lithium ferrophosphate, is that they have a life duty. They're rated at 5,000 discharge cycles, whereas LiPos are only rated at about 500 discharge cycles.
Oh,
So
really?
they clearly built it to last many years.
And aren't they also not near as likely to, run away in a bad way if they're overcharged? They're
LFP
safer.
cells don't have the positive temperature coefficient problem.
Less likely to catch fire, you're saying?
Yeah. Less liability is the bottom line, right?
Well, I think they also, if you buy a charger, like if you go to Amazon and buy a charger for that, you find that you can also charge lead acid battery. I mean, it doesn't have all of the finicky things of a LiPo charger. It's a little more simpler.
Yeah, I think Ron had won the prize for the puffiest cells. Those batteries he brought in one time there, it was supposed to be rectangular, but it was almost round, It's like, whoa. She's gonna blow.
Well, thanks, Paul.
Yeah.
That
Cool.
was good.
So what do you know what the going rate was for those? Are they like $2,000 mowers or?
I think I looked and it was like I think I remember looking it up and like you found an old Home Depot listing and I thought it was 1,800. Paul, does that sound right?
Yeah, back in that day.
Yeah, back in that day. Yeah.
That price.
Yeah.
Nowadays, I see this class of boundary wire mower selling around the $900 to $1,200 range.
So their Sensori's price of $100 for a box was, new in box was pretty good.
Yeah, pretty darn good.
Yeah.
I did get one other thing going, I guess, which was I got a microcontroller, and I should have left my phone on. Microcontroller running the dual DC motor controller that they were selling at Sensori, and anyway, it runs the motor forwards and backwards.
Cool.
You almost can't see it. Let me see if I should have. Sorry, I should have.
It just rolled. Does that mean it just turned on?
It twitched.
It twitches when it turns from the momentum.
Changes direction.
Yeah.
Oh, I see it's spinning there.
Yep, and there it goes. It rolled over. It wants to have its belly rubbed.
Right. Right. So that was kind of nice to see their controller work, and be able to drive their controller directly from an ESP32. So it's 3.3 volt compatible.
And then you got the blade motor going too, right? Using their.
Yeah, I've got the blade motor going. I don't have that hooked up anymore.
So could you show us the motor driver? Looks pretty small.
Yeah, let me just log back in with my phone so I can get okay, and let's see. Well, turn on video and figure out how to turn the camera around.
I wonder, does anybody have any experience with these mowers? Did they, actually bought one at some point and used it?
I had one.
Seriously?
No, they're all there.
Oh,
I've actually hooked mine up, and I've run it twice just in my backyard, just because it's a rectangle. So that's if you can't make it work on a rectangle, you're not going to be able to work on a. But we're on the lake in Little Elm, and I have about 1.2 acres of mowable. So I'm going to try to expand it and make it do a bigger area. But before we get our our one that mows in a line, back and forth like a person. I mean, this thing mows in a suit. It's like a Roomba, right? It just goes in random directions.
Yep.
And someone described it after the first pass, it looks like a bad haircut. Right? Because it just doesn't. It has to take multiple passes to get it off. But it does a pretty good job. I mean, I didn't see it. I didn't see any bad hair after it completed it after maybe 2.5 hours.
So it's sort of like the old Roomba.
Yeah, it's exactly like that. Yep.
Does the did the mower come with the charger?
It's all built in. It's a combination of what's in the battery pack and what's on the controller board. So it's all integrated.
No, I mean, do you have so it goes to a dock, right?
Right.
Does it have when you bought the mower for $100, did you get the dock?
Yes, everything is there. The dock, and then there's a power brick that puts 34 volts into the dock, and then you get the mower itself. It's all, you get everything. Yeah, actually, that's not true. The only thing that we didn't get that was taken out of there was the boundary wire. So you have to go buy that, but that's relatively inexpensive.
Yeah.
And then
I noticed when I looked at one of them, it seemed like there was a place for a controller to be plugged in or something. I didn't see the controller. I just said it looked like the indentation for a controller up on the top. You popped a plate and there it was like right underneath it. Did you see anything like that? Okay.
I didn't, but yeah, maybe Paul did.
A controller like on the mower?
Yeah,
Well,
like
let's say it was an acre and a half away, and you had to drive it by yourself. You wouldn't want to pick it up and carry it an acre and a half.
You got a phone app. You have a phone app that would drive that.
Yeah.
Okay, gotcha.
Or a Bluetooth phone app. In fact, you can connect to it. You can go change things up. You can do some of the stuff from the phone app.
So you said it was 2G, so that doesn't work anymore, right?
I don't think
Right,
so.
but the phone app uses Bluetooth.
Oh, you have Bluetooth. Okay.
Yeah, Bluetooth for the phone app. Yeah.
Got you. Well, that works great.
Yeah. And so this is the motor driver board that Sensori was selling. And it's just a dual H bridge. It's got an L298 style interface pins, with ENA and ENB and N1, N2 for the A and the B channel. And they come in on this 10-pin connector on the top left of the board. Motor voltage comes in on the bottom left, and then the two motor connectors go out the other side, and you can see the eight FETs. And it's just a dual H bridge.
Was that something they made or bought from AliExpress or something? Or?
It's actually, you can get it on AliExpress. It's an XY-160D. If you Google that, you'll find a data sheet from Hands On Tech, but AliExpress has lots of them.
What was the current rating on them, Paul?
Believe it's 7 amps.
That's what I believe it was. I bought that.
So that's the.
Do you have any specs on the motors yet?
What?
Did you get any specs on the motors?
No. No, I'm not expecting to. And then this is the blade
Oh,
modem,
yeah.
the brushless DC blade modem.
Mm-hmm.
And you know, I don't have high voltage hooked up to. I guess I could make it work, but as motor voltage comes in on the lower 2 pins on the left, and then those are the 3 motor phases going out the upper 3 pins. And then it's got a pot that you can use for manually setting the speed. And then down on the bottom right is a JST connector that goes off to the Hall sensors.
Yep.
Takes +5 ground and the 3 Hall sensor out.
EBC, yeah.
What?
Yep.
And then just to the left of the JST connector, you can see about 5 pads. That's a place where you can put another JST connector, and they bring out a couple of useful signals. A speed pulse signal that you can use for counting revolutions or measuring speed, and a PWM input.
Yeah.
And then
Yeah, one of the YouTubers said he got 95 pulses per revolution, and it's like, you sure that wasn't 96?
No,
95 seems like an odd.
that's not correct. So when running with these motors, which are a four pole rotor, 6 stator poles. In fact, so here's the 4 poles on the rotor that you can see, and the 6 stator poles. When running with that, you get 2 Hall effect pulses out per revolution, and you get, I'm trying to remember now, you get 6 of the speed pulses out per revolution. So every time it commutates, you get a speed pulse out. So anyway.
So Paul, just FYI, if you're interested, I've got my little blade motor set up here. I can show real quick.
Yeah.
Hooked up to the controller.
Go for it.
All right. So see if everybody can see that. I don't know why it's out of focus. Let me wipe the lens, see if that helps. All right. So I'm gonna try to see if I can hook this little LiPo up to it. And I don't know if you can hear it or not, but it's spinning.
Yeah, I wonder if these actually did like 6-step drive versus, sinusoidal.
I'm going to turn the speed control.
Or actually, I guess it would be like trapezoidal versus sinusoidal.
Y'all hear that?
No.
Oh.
Okay. There you go. You can see it going real. Can you see it going real?
Yeah.
Let's see here.
Yeah, you can see it.
Barely going, and then.
Yep.
Okay, that's it.
Mm-hmm. Yeah, is there some sort of shield or way to prevent the grass from getting up into those 2 motors? Was there, sometimes they have like a disc that kind of spins grass particles off, or out, or something like that. I kind of wondered.
Nothing beyond the
Starting your motor because it's corroded or something.
mounting bracket. There's a plastic mounting bracket that screws to the motor, and that forms a seal. So here's a motor with the mounting bracket on it, and
Oh, okay.
that mounting bracket rotates and pushes in and rotates and locks to the mower housing, to the blade housing. So there really isn't a way for grass clippings or dust to get up inside the motor.
And it's got kind of some kind of a watertight connector on there. You can kind of see that black connector here. Looks semi-watertight, or as watertight as you can get a connector.
Mm-hmm. Yeah, I was curious about that. There's all kinds of.
I was a little confused. Does the robot follow the lines, and so you have to have a zigzag pattern of lines for it to follow, or is it just a boundary?
It's
Just a boundary.
It's a early Roomba, I guess, right?
Yeah. It goes between it goes in a direction until it hits the boundary wire, and then bounces off at an arbitrary angle, I guess, and then goes a ways, and sometimes it'll go a ways in the open without hitting a wire and then turn around. At least that's my observation.
Mm-hmm.
Yeah, it's a Roomba-ish pattern, I think.
I'm assuming you haven't found a fecal detector on it?
I have one of those. It's called my foot.
Well, thanks, Paul. Paul.
Very good.
That was good. Give you a black star for that. Significant progress on figuring out how that works, what the sensors are, where they're wired to. I'm curious to see if you guys can get how you're going to get an RTK GPS tied in and get that going over time.
Yep, that's the plan.
Yeah, I think, Mike, you've used some of the 4G cellular, I don't know what you would call it. They're not for voice, they're just really for data transmission.
I use 2G, but yeah, it doesn't work.
Oh, you haven't used one of the 4G modules?
No, I haven't used it in a long time. Yeah.
A cellular modem, you can find them for like $7 on AliExpress, USB cellular modems. They just draw power out of USB, but they're essentially a hotspot.
Mm-hmm. Oh, okay.
The cost is in the plan.
Yeah. These were, I think Mike and I were paying the same amount. It was like $10 a month.
Yeah, $10 a month, and you get so many megabytes or whatever, or so many messages.
Right.
If you go above it, then it increments by another 10 or something.
Yeah. I think there were like narrowband IoT was one of the protocols, and then there was another one. Oh, cat something, I forget.
Yeah, there are a bunch of different plans you can get for IoT devices, depending on your bandwidth and data needs.
Yep. Yeah, the boards were pretty small. I think it's that one here somewhere.
Yeah, I had some property in Oklahoma, so I built my own alarm for the barn, and I communicated it with the 2G wireless. So the project was barn alarm. Yeah.
Now you could go Starlink.
With Starlink, you can do video, you can do everything. While we're waiting, I think Ray's looking for a board.
Yeah.
I posted some links that Ed shared with me this week.
I can't find it, so go ahead.
So I believe there's 4 robot related links there. Feel free to copy them out and go visit them.
So what? Okay.
How many
So-
robots does it take to run a grocery store?
What's that?
Is that it?
How many robots to run a grocery store?
Yeah, there was quite a few. It looked like a Amazon place. So I don't know if it was like a wholesaler or what it was.
I thought that was a joke. I was just waiting for the punchline.
No, it was one of the articles that he sent. Does anyone else have something to present tonight?
I just have a general question. This is the first time I think I've used Google Meetings or Meetup, whatever it is. The chat, is that persistent, or do we have to grab it now while the meeting is live?
You have to grab it now.
Yeah.
Okay. Thanks.
Goes away afterwards, right?
Yeah, we don't post the chat.
Pat, could you ask for that to be in the AI?
I mean, you do normally copy the link over though.
We used to
I
share
think
the
we
links
do.
in the chat, in the follow-up.
Yeah, I don't know if I have it.
I think it does all the links. It doesn't do necessarily all the chat, but it does the links, doesn't it?
It used to. I'm not sure it's
Some
so
of the
good.
links show up, yes, in the summary that I post. I usually post the links in the email that I send out.
Yeah.
So, but I see there's a transcribe, there's captions in the recording, and
It captures the chat. I mean, the chat is recorded. I mean, it's out on whatever our storage is, but I don't, it was an extra step to have to go out and pull it out every week. And it usually was like, hi, see you next week, because you are already capturing all of the links.
I'm just going to go look in our records, what we've got here. So I got a summary and I got a blog. So the blog is all of our talk. The summary is just the highlights from our talk. But I have nothing there for the chat, but I do have another folder to go look at. Let me go find DPRG. Groups, subscriptions, front page. AI demo. Okay. I gotta go deeper.
Couldn't hear you, Ray.
I said, did anybody look at the self-destructing humanoid one yet? It looks like they came prepared with a stretcher. They threw the thing on the stretcher afterwards.
So the last time I see a chat was on the 14th. Somehow it created the chat. So I don't know what I'm doing differently. Occasionally we're getting a chat.
Yeah, I think that's what I found was often the chat didn't have any useful information besides the links, and those were being captured already. So
Yeah, usually when I put out the DPRG list email, the links I capture in there. They're usually in the bottom.
Okay.
So if you're subscribed to the email group, you should see it.
Yes.
well, you can get them on the website every week.
I did make a little bit of progress on my Uno Q robot. I managed today to get a LIDAR working, reading back in, so over USB. I found a challenge. I've got a RP LIDAR C1 and trying to find a library that actually works with a C1. It's been trouble. I ended up having to go in and remove a line out of the Python driver where it was coming up with an error. And I went in and commented out, it was 2 lines to say that if there's an error, basically stop. And as soon as I took that error out, it works fine. So it does not seem to interfere with the operation, whatever. It was expecting I guess a 0 when it come out of something, and it found a 1, a checksum. And it wouldn't work. So I basically commented out the 2 lines that basically said to go to the stop routine, and it's spitting out data like crazy now. So I'm getting 420 to 427 readings per revolution. So it's typically I'm getting 1 or more readings per degree, and it's working. So I had it running for about 10 minutes, and it didn't stop, just kept churning along. So showing some progress. So I think I'm going to use it for a front-facing sensor to try to pick up, just whatever's in a certain view in front of the robot. So we'll see how it goes. I'm scrambling to try to get it done, but I'm working on it. So I have to convert it over to the UnoQ format. Basically to communicate between Python and the STM controller that's built onto the board. It's kind of handy. It's nice. It packs the data, so I can transfer several bits of data back and forth in the same message. And it works well that when you set it up, it'll automatically receive the data and jump to a function in Python, or send the data from Python and it'll automatically do like a callback in Arduino. So to process the data as you go back and forth. So seems to be working fairly well. Just trying to get it all pieced together.
Pat, did you ever make any progress on a shield or something you were saying that was going to be available in the future?
No, so there is one available in the future. Now there is one available. If you go to Arduino's website, they have one for a camera board. Okay. And I believe it'll hold 3 cameras, 3 or 4 cameras. I don't know if it has the processing power to handle 3 or 4 cameras. I did get it working using some OpenCV with a USB camera. And I was able to get it down to, I think the lowest resolution the one camera had was 320 by 180. So to do some vision processing, so scale it down so I'm not, working on huge images, a 2 megapixel image or something. And that seemed to work okay. For now, I'm trying to get the LIDAR working and see if I can use that for sensors to spot cans. So not much to show, just spitting out a bunch of numbers on the terminal. So I'm not going to do it for now. I want to see if I can get it to run the LIDAR to run in a, since it's using a real-time OS on the board, I'm going to see if I can get it to run in a thread, basically processing the LIDAR data and then spitting out the data back to the main Python loop. And see what I can do with that. So it runs in on a separate thread.
So a question just popped to mind, Pat. I'm sure you can send obviously you can send multi-byte messages, but can you send ints?
You can send, it's Python, so you can send ints, you can send floats, you can send all sorts of stuff, basically doubles.
And how do those turn up in the microcontroller? Do they need fixing somehow?
Well, so far everything has been working out. That's where I want to do a little more exploring to see, can I send a float back and forth, like a double or a float back and forth.
Well,
And
yeah, and I'm thinking about things like packing issues. Like if you send an int, which would be 4 bytes, or maybe 8 bytes in Python, up on a Pi, up on the main processor, down to the microcontroller. If you send a struct that is an int, then a byte, then an int, does it get sent as one struct, or does it get sent as 3 separate items, each with their own descriptor?
there is no descriptor, so you're expected to know what format the message is going to be on both ends. But I am sending, for instance, in one message, I'm sending 6 doubles, so floats, essentially, for my IMU. So I'm reading it on the Arduino and I'm passing it through to the Python. And it parses it. It's parsing it fine. I haven't tried putting an int in there and see what else it can do.
Yeah, I'm really, the interesting case is where you're passing a struct that has a float or an int, followed by a byte, followed by another float or int. And
yeah, I could try to inject like an int and a byte into my message that sends that I'm sending to Python to see how it would show up.
Yeah.
So I could put a counter or something, 0 to whatever, and put an int, and then put a byte in there as well, and see how they show up at the other end in Python.
That'd be interesting.
Yeah, and ESP now, you'd use a structure, and you could make any combination. It could be, characters, bytes, ints, floats, just as long as both sides knew what that structure was. So
I don't see it being as a structure in the Arduino or the Python end. So it's expecting separate values to come through. Not to say that you can't pack them into a struct when you receive them in the Python function or in the Arduino function.
Yeah.
But unpack them into that structure. For now, all I've seen so far is just sending the individual members in a pack message, essentially. So it takes care of the packing. You just, hey, send this, 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 and this.
Okay.
So I will intersperse it with different formats and see how it turns out.
That's just curious. It's one of the classic challenges is dealing with layout in memory and Indianness when you try and get computers to talk to each other. So, but probably they've looked after all of that.
Yeah, so far it looks to be working, but I will confirm whether you can, like you say, send different values interspersed with whatever, different formats.
All right. I'm going to drop off. Good night.
But Mike.
Right.
Yeah, that was a little weird with ESP now. They said your payload can only be 250 bytes. So I think whatever you were sending, you had to try to figure out, okay, I've got 8 bytes here, 4 bytes here, because I think it just truncated your data if you sent over 250. You lost the voice. We can't hear you. It's just crickets. No.
It's a sign.
Well, did we run out of topics?
Pat ran out of microphone.
It's like, Pat can't end the meeting now. What do we
I
do?
know.
All right.
I got the big red button. I can hit it.
Oh, you,
All right. Good talking to you guys. See you on
Thank
Saturday.
you.
See everyone on Saturday.